Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 6-5, multiplying polynomials. Alright, so a monomial is a number, a variable, or the product of a number and one or more variables raised to whole number powers, such as 5x, negative 8y, and 3x squared y to the fourth. A polynomial is a monomial or a sum of monomials. Each monomial is the expression, and the expression is called a term. A polynomial with two terms is a binomial. You can multiply two binomials using algebra tiles. Multiply two binomials using algebra tiles. To use algebra tiles to multiply 2x plus 1 times x plus 3, first represent 2x plus 1 vertically along the left side of the algebra tile diagram. And x plus 3 horizontally along the top. Then use x squared tiles, x tiles, and 1 tiles to complete the diagram as shown below. 2x times x plus 3. 2x times x plus 3. Okay, so you're going to get 2x squared plus 6x, right? 1, 2, 3, 4, 5, 6. So x times x is x squared. X times x is x squared. So there you have 2x squared plus 1, 2, 3, 4, 5, 6 plus 6x. Okay? So then 1 times x plus 3. 1 times x plus 3. 1 times x is x. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. So you have here x plus 3. And it's 1x or x, right? The 1 you don't have to put. So 6x's plus 1x is 7x's. So when you multiply them out, you get x squared plus 7x plus 3. The product is a trinomial, a polynomial with 3 terms. Another way you could do this is just by FOILing it out, which we are going to get to on the next page. So look, and it's a trinomial because there's 1, 2, 3 terms. Okay, so looking at the algebra tile diagram, what two terms in the original binomials combine to form the x squared term in the trinomial? So that would be 2x and x, and they combine by multiplying. Look at the algebra tile diagram. What two terms in the original binomials combine to form the constant term of the trinomial? How do they combine? So it's going to be the 1 and the 3, right? And they combine by multiplying. Look at the algebra tile diagram. Show how the terms of the original binomials combine to form the x term in the trinomial. We have 2x times 3 plus 1 times x, and that equals 7x. You can verify that the expressions are equivalent by substituting a value for x into both expressions and simplifying to show that they are equal. Verify that expressions are equal. Use x equals 4. You'd have 2 times 4 plus 1 times 4 plus 3, which would give us 2 times 4 squared plus 7 times 4 plus 3. 9 times 7, 2 times 16 plus 28 plus 3. We're going to have 63 equals 32 plus 28 plus 3. 63 equals 63, so we know, yes, they are equivalent. Suppose you want to use algebra tiles to find the product of 2x plus 1 times x plus 2. Describe how you would modify the algebra tile diagram to find the product. So you would have to remove the last column of the tiles from the diagram, right? Because you have plus 3, and here you want to do plus 2, so you're going to remove the last column of tiles. product becomes 2x squared plus 5x plus 2. Suppose you want to use algebra tiles to find the product of 2x plus 2 times x plus 3. Describe how you'd modify the algebra tile diagram to find the answer. So you would add a row of tiles to the bottom of the diagram that is identical to the bottom row. This adds 1 x tile and 3 1 tiles to the product, which becomes 2x squared plus 8x plus 6. Using algebra tiles to multiply two binomials is a useful tool for understanding how two binomials are being multiplied. However, it is not a very practical method for everyday use. Using the distributive property is. To multiply 2x plus 1 times x plus 3, use the distributive property. You distribute the binomial x plus 3 to each term of 2x plus 1. You then distribute the monomial 2x to each term of x plus 3, as well as the monomial 1 to each term of x plus 3. Alright, so basically all you're doing is you're taking the first term and you're going here and here. Then take the next term, go here and here. Okay? So we get 2x times x is 2x squared. 2x times 3 is 6x. 1 times x is 1x, and 1 times 3 is 3. And you add that all together to get 2x squared plus 7x plus 3. Notice that the product found using algebra tiles in the Explorer is the same as the product found here using the distributive property. Thus, the two methods are equivalent. To multiply 4x minus 7 times 3x plus 6 using the distributive property, you would think of 4x minus 7 as 4x plus negative 7, and therefore keep the negative sign with the 7. All right, so you're distributing the 4x. So you go 4x times 3x is 12x squared, 4x times 6 is 24x, negative 7 times 3x is negative 21x, and negative 7 times 6 is negative 42. And then you just combine all those like terms, and you get to 12x squared plus 3x minus 42. This method of using the distributive property to multiply two binomials is referred to as the FOIL method. The letters of the word FOIL stand for first, outer, inner, last, which will help you remember how to use the distributive property to multiply binomials. You apply the FOIL method by multiplying each of the 4 pairs of items described below and then simplifying the resulting polynomial. First refers to the first terms of each binomial. Outer refers to the 2 terms on the outside of the expression. Inner refers to the 2 terms on the inside of the expression. And last refers to the last terms of the binomial. Now multiply 7x minus 1 times 3x minus 5 using FOIL. Again, think of 7x minus 1 as 7x plus negative 1, and 3x minus 5 is 3x plus negative 5. This results in a positive constant term of 5 because negative 1 times negative 5 is positive 5. Okay? Notice that the trinomials are written with the variable terms in a descending order of exponents and with the constant terms last. This is standard form for writing polynomials, starting with the variable term with the greatest exponent, write the other variable terms in descending order of their exponents, and put the constant term last. Refer back to the Explorer. Using the tiles you multiplied, 2x by x plus what? It was x plus 3, guys. And then multiplied 1 by x plus 3. You are using what property? The distributive property. In FOIL, which of the products combine to form the x term? Outer and inner. In FOIL, which products combine to form the constant? The last. Which products combine to form the x squared term? The first. Two binomials are multiplied to form a trinomial. When is the constant term of the trinomial positive? When is it negative? So when the original constants are both positive or both negative, when one original constant is positive and the other is negative. Multiply 12x minus 5 times 3x plus 6 using the FOIL method. 12x times 3x is 36x squared. Negative 5, wait, what is outer? I guess outer's these two, right? 12x times 6. What is 12x times 6? 72x. Inner. So it's first, outer, right? First, you go to the first and first, outer, inner. Negative 5 times 3 is negative 15x. And then last, negative 30. Combine these, and you get 36x squared plus 57x. 72 minus 15 is 57x minus 30. Right? First, inner. First, outer, inner, last. I just like to, to me, I never say FOIL in my head, ever. All I do is I take the first term and I distribute it to this and then this. I take the next term, distribute it to this, and then this. If there was 2 terms and 3 terms, then I would take this to all 3 terms, then this to all 3 terms. I just work from left to right, right? Making sure I distribute it to everything. And then I move next to the next number. So if I had a trinomial and a trinomial, I take the first term of the first trinomial, put it to all 3 of the other all 3 of the second trinomial. Next term, the middle term of the first trinomial, put it to all 3 of the next one. The third term of the first trinomial to all 3 of the next trinomial. And you literally just work from left to right until you've done everything, and then you're good to go. How does the final x term in the answer to the example relate to your answer in question B to be explained? All right, so the final x term, 57x, is the sum of the outer product, 72x, and the inner product, negative 15x. How does the final constant in the answer to the example relate to your answer in question 2C? Explain. The final constant term, negative 30, is the product of the last 2 terms, negative 5 and 6. How does the final x squared term in the answer to the example relate to your answer in question 2D? Explain. The final x squared term, 36x squared, is the product of the first 2 terms, 12x and 3x. Suppose the problem in the example 12x minus 5 times 3x plus 2. Would the x squared term in the product change? Would the x term change? Would the constant term change? Explain your reasoning. Okay, so would the x squared term in the product change? So what would we have first off if we had this? We would have 36x squared plus 24x minus 15x minus 10. We'd have 36x squared plus, what is 24 minus 15? 9x minus 10. Okay, as opposed to our, this, right? So, does the first term change? No. Does the second term change? Yes. Does the third term change? Yes. Right? This changes and this changes. This stays the same. The first terms are the same. The x squared term only depends on the first terms, so the x squared term doesn't change. One of the outer terms is different, so the product of the outer terms affects the x term, so the x term will change. One of the last terms is different. The product of the last terms produces the constant term, so the constant term will change. Okay, so when you multiply this out, you get 36x squared plus 9x minus 10. Okay. As with binomials, you can multiply two polynomials by using the distributive property so that every term in the first factor is multiplied by every term in the second factor. You can also use the product of powers property. So a to the m times a to the n. When you're multiplying exponents with the same base, you add the exponents, a to the m plus n. Each time you multiply two terms. All right, guys, so when you're multiplying polynomials, find the product. Okay, so I'm taking this first term, this monomial, and I'm distributing it to everything in this trinomial. 4x squared times 2x to the third, 4x squared times negative x squared, 4x squared times 5, right? So we're going to get 8x to the fifth minus, a positive and a negative is a negative, 4x to the fourth, 2 plus 2 is 4. 5 times 4 is 20. X squared. Is everyone clear on how I did that? All right, so let's try another one. So use the horizontal arrangement. Okay, so we're going to distribute this to everybody. X times negative x squared, x times 2x, x times 1. Now I go to the next one. Negative 3 times negative x squared, negative 3 times 2x, negative 3 times 1. All right, so that'd be 2x squared. X times 1 is 1x or x. Negative 3 times negative x squared is positive 3x squared. Negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. Bring down everything. It's this. What's going on here? Oh, we have a squared. Okay, so there's this one and this one get combined. 3 plus 2 is 5. 1 minus 6 is negative 5. And bring down my negative 3, right? These two get combined, and then this one's by itself. Combine like terms. Use a vertical arrangement. Okay, so if I had negative x squared plus 2x plus 1 and x minus 3. What are they doing here? Oh, they're multiplying this by this? Okay. So they're first taking this and multiplying it here, it looks like. What are they doing? They're multiplying it by negative 3. So if they're multiplying by negative 3 first, negative 3 times this, this, and this. Then they're multiplying by x times these. So x would be negative x to the third, 2x squared, and x. And then they're going to add them vertically. So you have your negative 3, you have negative 5x, and you have 5x squared. Is the product of the two polynomials always another polynomial? Yes. Right? Yes. After using the distributive property and multiplying monomials, the product consists of a sum of monomials, so it's a polynomial. Because a monomial is a polynomial, right? It's at least a monomial. If one polynomial has m terms and the other one has n terms, how many terms does the product of the polynomials have before it is simplified? The product has m times n terms before it's simplified. Alright, so let's do some of these practice problems together, and then your homework tonight is going to be page 355 and 356, those extra practice problems. Alright, so let's look here. I want you guys to try number 1 real quick, and then we will go over it. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. Combine like terms. X squared plus 5x plus 6. You guys able to get there? Try number 2. Or actually, yeah, try number 2. You guys get to x squared plus 18x plus 77. You do x times x times 11, 7 times x, 7 times 11, and you add it all together. Try number 3. You should get 2x squared plus x minus 78. Because you did 2x times x is 2x squared, 2x times negative 6 is negative 12x, 13 times x is 13x, and 13 times negative 6 is negative 78. Combine like terms. So you combine the negative x squared and the plus 13x. You combine those into x. So you get 2x squared plus x minus 78. Try number 5. You're distributing that monomial to each of the 3 terms of the trinomial. So 2 times 2 is 4. X to the 3rd times x squared is x to the 5th. 4x to the 5th minus 2 times negative 9 is negative 18. So you're going to end up with negative 18x to the 4th plus 6x to the 3rd. Perfect. Yeah, I can see it's moving now. Thank you so much. Appreciate it. You too. Sorry about that. We got our AC fixed. Yay! All right, guys, is everyone okay on number 5? Yes? Number 7. That's going to be 12x to the 5th plus 2 times 4 is 8, x to the 4, 5, 6, minus 30x to the 3rd, minus 20x to the 4th. And then rearrange into descending order. Oops. At 8x to the 6th plus 12x to the 5th minus 20x to the 4th minus 30x to the 3rd. Try number 9. And raise your hand if you're not getting the right answers. So we're good? Have you guys seen this before, or is this the first time? You've seen it before? Okay. All right, this one was kind of messy. It's x to the 3rd plus 3x squared y plus 3xy squared plus 2y to the 3rd. I hope you guys enjoyed this lesson on 6.5, multiplying polynomials. Please like and subscribe and have a fantastic day.